So in this part, we're going to create an EKS cluster manually using AWS Management Console. And there are a couple of things involved in creating EKS cluster in AWS. And here are the things we're going to do. First, we're going to create an IAM role for EKS service that will give this EKS service certain permissions to create things in our AWS account. As a second step, we're going to create a VPC where our worker nodes are going to run. As a third step, we're going to create an actual EKS cluster. This is a set of control plane nodes that are managed by AWS. And finally, when the cluster is created, so the control plane nodes are up and running, we're going to connect to that cluster using kubectl command line tool from our local machine. So next, we're going to have to create the worker nodes for the EKS cluster. For that, first we're going to create a role that we're going to assign to EC2 service to give it certain permissions to call AWS API and configure and create stuff in our AWS account. So we're going to have the second role now for EC2 service. And then we're going to create a node group, which is a group of EC2 instances that are going to run as worker nodes in this Kubernetes cluster. And we're going to attach the node group to the EKS cluster. So now we're going to have the worker nodes connected to the control plane nodes. So we're going to end up with a complete Kubernetes cluster with control plane nodes managed and running in an AWS managed account and worker nodes running in our account. And once we have the fully fledged Kubernetes cluster, we're going to configure autoscaling for our cluster. So basically, based on the resources required by the cluster, how many pods we want to run, how many applications we want to deploy in the cluster, the number of EC2 instances or worker nodes will be intelligently scaled up or scaled down to match these resource requirements. And finally, in our configured autoscaled cluster, we're going to deploy an example application and we're going to see how this all works in action. Now, the first thing we need to do in order to create an EKS cluster is create a role in our AWS account that will have some permissions attached to it or some policies attached to it. And we're going to give that role to an AWS services outside our own account. So this is going to be for the services that are managed by AWS because EKS cluster is managed by AWS. So we are going to give that role to AWS to manage, create components in our AWS account on our behalf because that's what role basically is. And also as part of the role concept in AWS, you can actually give roles from your account to another AWS account, so that services on another account can manage components and services on your account. And that's exactly what we are doing. So we're going to create a role that has permission policies specifically for EKS cluster. So let's go and do that first. I'm going to go to IAM because that's where we can define roles. And here I have the list of different components in IAM. Let's go to roles. And note one thing here is that IAM service is actually not defined per region, but it's rather global for your whole account. And here you see the part where usually you see the region. Now it says global. So if you have created roles or users or groups, they're basically available for the whole account for all the different regions. So these are global components. And if you have created any roles or groups, they're going to appear all in the same list. So let's go ahead and create our EKS role. So we're going to give that role to the EKS that AWS will manage for us. So the service that we're going to create or assign the role to is going to be EKS. So we're going to choose it from here. So AWS services, we're giving the role, attaching the role to AWS service, EKS. So I'm going to click on that. And here we have a list of scenarios for this role. We're going to choose the EKS cluster use case and click on next. So this is automatically selected policy for you. So basically the use case that we just selected needs this specific policy. And if I expand it, you're going to see the list of permissions that Amazon EKS cluster policy contains. So it has permission for EC2 service, again, on our AWS account, the auto-scaling permission, elastic load balancer, and so on. And as I said, the policy is automatically selected for us for the use case that we chose. So I'm going to click on next. And this is basically a summary page for my role. So first we're going to give it some unique name. Let's call it EKS cluster role. And here we have two pieces of information about this role. The first one is basically which service is allowed to use that role. So which service are we attaching the role to? And in our case, it's EKS service. So EKS service will be able to perform the things allowed by list of permissions that we just saw on our behalf. So it's going to be able to do stuff with EC2, IAM, the elastic load balancer, and so on. Because again, remember, EKS is going to manage our cluster for us. It's going to create the pods on the EC2 instances. It's going to check the information from our nodes, etc. So we are allowing EKS to do all of this using that role. So attaching that to EKS service is one piece of information. And another one is what EKS is allowed to do with that role. And this is the policy that we gave. This is an optional text space, so we can actually tag the role with some metadata information. So for example, if you have multiple rows and the names aren't that distinctive, you can add some more information to the rows. We're going to leave it blank. And with this information, we can create our role. Awesome. So the EKS cluster role got created. As a next step, we're going to create a VPC for our EKS cluster. As you know, you have a default VPC that AWS automatically creates for you in every region, right? So we have already a VPC, the default VPC that was created, and we also have subnets in that VPC and route tables and so on. So all the components for the VPC, for the network configuration are already there by default. So the question is, why do we need to create a new VPC for EKS cluster when we already have an existing VPC with all the components? The answer is the EKS cluster needs a specific configuration of networking for it to work without problems. You have to remember that EKS is based on Kubernetes, right? So Kubernetes has its own networking rules, and AWS on top of that has its own networking rules, right? And concepts. So these two need to work together. And for that, VPC configuration has to be configured correctly. And the default VPC is not optimized for EKS cluster, or at least the best practices for running an EKS cluster. Another important note here is that when we create a VPC in order to create the EKS cluster, this VPC is a network that is going to run your worker nodes. So it's not the VPC that we're creating for the EKS or the master nodes, but rather for worker nodes. So this is the VPC on our account, and this is where the EC2 instances, or basically the compute resource, the worker nodes of Kubernetes cluster are going to run. And to give you an idea, some of the examples of this configuration, this specific configuration that Kubernetes or EKS cluster needs are, for example, the firewall rules, right? Each VPC has subnets, and subnets have their own firewall rules, right? Each subnet can have different firewall rules. which are configured by NACLs, Network ACLs, access control lists. And inside the subnets, you have EC2 instances, and these EC2 instances can also have their own firewall rules, which are defined by security groups. So basically, your worker nodes, which are going to run in your VPC in different subnets, need to have a set of firewall configurations that is necessary for control plane nodes to connect to your worker nodes and also to manage them, because they are going to need to communicate with each other. And again, you have to remember EKS is running on different VPC, which is managed by AWS outside of our AWS account. And the worker nodes for that Kubernetes cluster are going to run in our VPC managed in our AWS account. So the communication needs to work between the control plane and worker node across those different VPCs. And for that communication, all the necessary ports need to be configured correctly. Another configuration example for your VPC that is kind of specific to EKS is a best practice for creating and configuring subnets in your worker node VPC. And that configuration is having public subnet and private subnets. So a mixture of those. So that means when you create a service, for example, in Kubernetes, which is of load balancer type, a service gets created and also automatically a cloud native load balancer gets created. So in AWS, it's going to be Elastic Load Balancer. So what happens is that when you configure your subnets into private and public, Kubernetes will know to create that external load balancer in a public subnet, because you want that load balancer to be accessible externally. So you want to create it in a public subnet that allows external connections. And in addition to that, to basically giving this information to Kubernetes or control plane on EKS to our worker node VPC, you also give Kubernetes permission to change things in our VPC. Of course, that happens through a role that we just created. And that permission is basically to open ports on our behalf in our VPC. Again, for example, if you're creating a node port service, that means that your worker node needs to open a port so that it's directly accessible on that node port, right? So that port needs to be opened. That's a firewall configuration on a security group and the subnet. So control plane will actually do this automatically on our behalf. So we're also delegating that permission through a role. So this is kind of an overview of why we're creating a role and why we're creating a VPC and giving that VPC information to EKS when we create the EKS cluster. Now, as I said, the VPC that we create for our worker nodes needs to have all these EKS specific configurations with the best practices suggested by AWS. And that's the reason why we're creating the new VPC. However, we don't have to figure out and configure all this stuff by ourselves. What we can do instead, AWS has templates with all this stuff pre-configured that we can use when creating a VPC. So instead of creating the VPC ourselves and then setting all the configuration that we need, we're going to use that template. And that template is a CloudFormation template. So we can create a whole stack of components with the configuration suggested by AWS through CloudFormation template instead of configuring everything ourselves right here. So what we're going to do is we're going to go to CloudFormation, which is an infrastructure as code tool specifically for AWS. And we're going to create that whole stack, the VPC and all the components, security group, internet gateway. So basically all the components that VPC needs, the subnets and its configuration, we're going to create the whole stack using that template in CloudFormation. So let's click Create Stack. And that's another cool thing with working with infrastructure as code. Generally, you have defined or predefined files with all the configuration necessary that basically describes what needs to be created with which configuration, and you can use that file to create a bunch of stuff and configure them. So you spare a lot of time and a lot of effort in these things. So here you see template is selected, and the template is also hosted on S3 bucket. So it's publicly available on AWS S3 bucket URL. And there's a page in AWS EKS documentation where you can see all these URLs. So you basically have three choices. Either you're creating a VPC with all private subnets, or you're creating VPC with only public subnets, or you're creating a mixture of those, which, as I said, this is something recommended by AWS itself. It's a best practice to have a combination of public and private so that Kubernetes can use them for different purposes. So we're going to go ahead and copy the link to the template that will create VPC with public and private subnet. So let's go ahead and take the template URL, which will create public and private subnets. And of course, there are a bunch of other configuration inside, and we can actually take a look at that before using it. So if I type that URL, the YAML file gets downloaded, and that's basically the contents of that template. And this is the whole stack, right? We're creating multiple components using one template file. We have the VPC itself, we have the subnets, and for the VPC and for the subnets, we have the CIDR blocks, which are basically the IP address ranges. So the VPC has the IP address range that gets distributed or divided among its containing subnets. So each subnet will now have its IP address range, which is very important part in Kubernetes configuration, because in Kubernetes cluster, as you know, each pod will get its own IP address. So this is the range of IP addresses that will be used to assign the IP addresses to components in Kubernetes cluster. So all this information is obviously very crucial and necessary for control plane, so that the control plane processes can assign these IP addresses to Kubernetes components. And if we scroll a little bit down, we have a bunch of other resources like Internet Gateway, the route table, and all sorts of things. Now, you don't need to know all this stuff. These are network configurations for your private network, and usually you won't need to configure them or adjust them. They're set by default by AWS. Also, when you create a VPC without a template, and they're configured properly by AWS. Now, generally, for most of the use cases, this template configuration, which is specifically designed for EKS cluster, must be enough. However, if you still needed to do some advanced adjustments, for example, increasing the range of IP addresses because you know you're going to have loads of pods and other components in your Kubernetes cluster, so you want to have much bigger range of IP addresses available for your VPC, for your worker nodes. In that case, you would just adjust this template file and then you can upload it right here. We're going to take that URL directly from S3 bucket and paste it in here. And that's really it. This is basically all we need to hand over to CloudFormation, and that will take care of creating a VPC with all the configuration and optimizations for the EKS cluster. So we're going to do next. Let's give the stack a name. Let's call it EKS worker node VPC stack. And here, as you see, you have a possibility to configure the IP address ranges before creating the stack. And as I said, if you know that you're going to be creating a lot of components in Kubernetes and you want to increase the range of IP addresses available for your VPC and individual subnets, then you can change the configuration here, or maybe give one subnet more IP addresses than other ones, then you can do it here as well. And let's do next. And we're going to leave everything else as is. This is some advanced configuration right here. We're going to skip that and let's do next. And now we have the summary page. So let's review it quickly. We have the template URL. We have the CIDR block configurations for VPC and the subnets. And we have skipped all the rest of the configurations. So now let's actually create the stack. And you see the status here, create in progress. Let's refresh it. So basically all the components in the stack are being created right now. So this is the complete VPC stack. Here you see 22 resources got created. The creation is complete for all the resources. And now if you go to outputs, you are actually going to see 3 resources or components that you are going to need as information for EKS cluster. So EKS cluster needs to know which VPC of your AWS account you want to use for deploying the worker nodes, because obviously now we have 2, right? So when we create EKS, we're telling the control plane or AWS that is going to manage our worker nodes, we're telling which VPC it should manage. We're also giving information about the subnet IDs in that VPC and also the security group that we're using in that VPC. Again, you might have multiple security groups, so we're gonna need to tell EKS which one we're using for our worker node group, so to say. So now that we have the role that will let EKS do things on our behalf in our AWS account to basically manage our worker nodes and other resources, and we have a VPC in that our worker nodes will run. And with these 2 sets of information, we can now create an EKS cluster. So let us actually open this in a new tab. So let's find EKS service. And we don't have any EKS cluster running yet, so we can create the one now. And note that EKS cluster is not free, so you will be charged for using EKS control plane. And you have all the pricings for EKS here, so you will be basically charged for the control plane nodes managed by AWS for the duration of time that you use the EKS cluster, because control plane nodes are obviously also running on EC2 instances, so basically on virtual machines, and plus using some other AWS services. So that's why as a user, you basically pay for AWS to manage the combination of all those services for you. So the first thing is, let's just provide the cluster. Let's just call it EKS cluster test. Next step, here we have the Kubernetes version. Let's leave it at default. And here we have the role selection. And this is obviously the IAM role that we created for EKS. And as you see, it automatically found the correct role and already selected it here. So if I click inside, I get that as a default option, so to say. So that one is selected. This is an interesting part right here, actually, because as you know, Kubernetes has components called secrets, right? And secrets are stored in base64 encoded form. Now, base64 encoding isn't very secure. So you have secrets with confidential information. So if somebody was able to get into your Kubernetes cluster, they will be able to pretty easily see the contents of your secret using kubectl or Kubernetes dashboard. So it's not a very secure way of storing the secrets. And if you need that security, you can actually encrypt your secrets, right? And for that, you have to install additional tools inside your Kubernetes cluster for encrypting the secrets. And AWS happens to have a service for encryption. And in the managed Kubernetes service, you basically have an option, because AWS services, they're all integrated tightly integrated with each other. So you have an option of using the Kubernetes key management service to encrypt the secrets in your Kubernetes cluster. And this is exactly the toggle for enabling that. So again, if you need some security in your cluster, it is actually a good practice to encrypt your secrets, and you have an option of doing that using AWS Key Management Service when creating an EKS cluster. So that is an option. But I'm just going to leave it as is for our example, and let's go to next. So role is configured already. We are giving EKS access to our account's resources. Now, the second one is networking. We need to specify or give information to EKS about our networking, where our worker nodes will run. And here you see the default VPC got collected. However, we created a new VPC for EKS with all the needed configuration for the EKS. So we're going to choose that one. So let's choose it. And automatically selected, you get the subnets of that VPC. In the same way, we also need to select a security group. Now, because we have two VPCs, we have security groups for each VPC. So we need to select the correct one of that EKS worker node VPC. And this is another interesting bit of configuration for your EKS cluster. So you have a choice between public, both public and private, and then just private. Now, not to confuse with the configuration with subnet, this is entirely different thing, and it has to do with configuration of accessing your cluster. So as you know, we have the control plane, or we are going to have a control plane managed by EKS, and we have our worker node VPC, right? We have these two VPCs. And Kubernetes entry point, which is the API server, is one of the control plane processes. So it is going to be deployed and running inside the EKS VPC, meaning this is going to be an AWS managed VPC. So if we want to connect or talk to our Kubernetes cluster externally, for example, we want to be able to access the API server or the Kubernetes cluster from dashboard or kubectl externally, outside the VPC, basically, outside both of these VPCs, we need to enable a public endpoint. That means you can run kubectl from your local laptop, or you can access Kubernetes from a dashboard, from a browser, when you have public cluster endpoint enabled. So what is the private endpoint? The private mode is enabling the worker nodes to communicate or connect to the cluster endpoint within your VPC network. So private mode basically will enable the control plane nodes and the worker nodes to talk to each other through our VPC, the worker node VPC that we create. So a network interface will get created in our VPC that would enable the traffic to go from our worker nodes through our VPC directly to the control plane nodes. And that is actually the optimal configuration. So we have a public cluster endpoint, which means I can talk to my cluster from my laptop using kubectl, or I can create a dashboard and access the cluster through the browser, also from my laptop. However, my worker nodes can talk to the control plane nodes directly through the VPC because of this network interface. So that would be public and private mode. The other choices, obviously, if you have just the public endpoint open, then the worker nodes will also need to talk to the control plane nodes or the cluster endpoint through that public IP address. So it will be a less efficient communication way between worker and control plane nodes. So they will have to leave the VPC they are in and go on the public route, just like other services or other clients like kubectl and so on. And then you have the private mode, which basically means that the worker nodes can access the control plane nodes through its VPC. However, other external services and clients cannot access Kubernetes endpoint directly on the public endpoint. Like I can't execute kubectl commands from my laptop because my laptop is not in the VPC and the public endpoint is not open. That means we would have to install kubectl client on one of the worker nodes or on a server which is part of that VPC to actually connect to the API server to deploy stuff or to view stuff from Kubernetes cluster and so on. So you won't be able to configure kubectl to talk to the API server from your laptop. That's the difference. So we're going to choose public and private because that's actually the optimal configuration for the cluster, and we're going to do next. So this is a configuration for logging for your control plane. So basically, you are able to decide if you want to see the logs that come from the master processes. So all the requests to API server, the authentication events, what the controller manager does, the scheduler does. So you can basically enable logging for all these different processes on control plane if you want to see what's going on in the control plane. Now, obviously, the control plane is managed by AWS. So they are monitoring, they are tracking, and they are logging all this stuff when managing all these for you. So you don't have to worry about fixing the control plane nodes. And this is basically just an additional step. If you're curious about what's going on in the control plane nodes, you can enable these logs just for your own information. But obviously, this is all done anyways by AWS for the control plane. And next, we have some Amazon EKS add-ons available to our cluster. Core DNS is a Kubernetes process that is going to add DNS services to our EKS cluster. What this means is that this way we'll be able to use DNS names inside the cluster to communicate instead of just using the IP addresses. So it will help with IP address resolution when using the DNS names to address different services in the cluster. And this is a default service that is usually enabled on all Kubernetes clusters, and we will enable it here as well. Then we have kubeproxy as another add-on, which is a service that basically manages some networking tasks like routing in our cluster. kubeproxy is going to run on all of our nodes and forward all the traffic between services and pods using these routing rules and make sure that all of the parts of the cluster can communicate. And then we also have the Amazon VPC CNI plugin, which stands for Container Network Interface. Again, this is another networking service that is going to enable easier communication in our cluster. So basically, the Amazon VPC CNI creates this network layer within the cluster so that all the pods running on all these different nodes will communicate with each other as if they were running on the same server, on the same local network. So the CNI plugin will basically allocate the pods, the IP addresses from the IP address range allocated to the cluster through the AWS VPC. So this way our pods are going to be able to communicate to any other AWS resources if needed. And finally, we have a security plugin available from AWS, which can detect any security threats and make them available in another AWS service called Guard Duty. And this is not a free service or something that usually deploy in Kubernetes cluster by default. And this is pretty AWS specific as well. So we're actually not going to use it or install it in our cluster. We're just going to go with the 3 default add-ons that are already selected here. So if I click next, we can just accept the default versions of these add-ons and click next again. So with this configuration, we're finally on the review page, the summary page. There is actually not much that we have configured here. It's pretty straightforward. We assigned the role to EKS and we provided information about the VPC, subnets, and security groups. And if we go back to the CloudFormation stack, where we created the VPC stack, in the output, this is exactly the data that we see in the output tab. So this is the information that we provided in the EKS cluster creation form. So with this configuration, we can now go ahead and create an EKS cluster. So EKS cluster creation is going to take around 10 to 15 minutes because AWS is going to create and provision lots of resources in the background. And the cluster info status is going to change to active once all the resources are provisioned and the cluster creation is complete. And now that we've created the cluster, we can actually connect to it using kubectl from our local machine. And even though we don't have the worker nodes yet, the node groups is empty, we can still talk to the API server because the control plane is still running. So let's actually go to our terminal and configure our kubectl to connect to the EKS cluster. And the way we do that is by creating a kubeconfig file for the newly created EKS cluster. Now our default region that we have configured can be seen here if we run AWS configure list, which is basically going to list the configuration details that we have set already. And this is the region that we have used to create the cluster as well. So that's where a cluster is running. That means we don't have to provide a region configuration here. Everything is already aligned. And the command is update kubeconfig. AWS EKS update kubeconfig. And this will create a kubeconfig file locally. And this file should have connection information for a cluster that we define by the name. So the name takes the cluster name as an attribute. And this is our cluster name. So let's copy that. And there you go. And if I execute this command, there you go. We have created the kubeconfig with all the needed information to connect to the EKS cluster. And that file is now located in .kube/config. And if we look inside, in this kubeconfig file, you can have multiple cluster credentials configured for multiple different Kubernetes clusters. And for each of those clusters, it will actually create a context entry in this file. And to know which cluster you want to connect to at any time when you execute kubectl commands, since kubectl command by default will use this kubeconfig file in this default location, the current context is a set in this file. So that's what kubectl will use as a current cluster context to basically connect to that cluster. And as you see here, it's set to our EKS cluster. Since we executed the AWS command, so it automatically set the current context in this file to that EKS cluster. So if we do kubectl get nodes, no resources found because we don't have the worker nodes yet. Now, if I do kubectl get namespaces, so these are namespaces that contain Kubernetes processes. If I do kubectl cluster info, I'm going to see the information about the Kubernetes cluster. So I have the API server endpoint, and this should be the same endpoint that we see in the details of our cluster. So that's the same endpoint. And now our kubectl is talking to the EKS cluster, the API server in the control plane at this endpoint. So we have a connection to the control node. Now it's time to create worker nodes so that we can create and deploy pods in them. Our cluster is active, and here we can see some auto-generated information for our cluster. So let's go to the details view first. This is the API server endpoint. Basically, this is where Kubernetes API server is accessible at. And because we have selected the public accessibility mode for our cluster, we can talk to that endpoint from external clients. And these are some other information, obviously the role that we assign the cluster and the cluster or EKS cluster unique ID. Let's go to compute. And here you see we have three sections, either nodes, node groups, or Fargate profiles. And as I explained previously, you can run the pods or the workload on your worker nodes in Kubernetes, either using EC2 instances, so the pods will be scheduled on EC2 instances, or you can, as an alternative, use Fargate. And Fargate will then, in the background, provision the virtual machine that will run the pod, because that pod obviously needs to run somewhere, right? And again, to summarize the difference, node groups are the EC2 instances that you have to manage yourself, and Fargate basically gives you the managed worker nodes on top of managed control plane nodes. What we're going to do for our first example is actually add node group. So we are going to run the pods on EC2 instances. So we're going to have EC2 instances as worker nodes. Right now it is empty because when you create EKS cluster, only the control plane gets created. The worker nodes still have to be created by you. So that's empty right now. Let's go to networking. And this is the networking configuration that we have created and passed on to the EKS cluster. So that means that the control plane is already running. It's managed by AWS. And now we have to create the worker nodes and connect those worker nodes to the control plane. And the way we are creating node groups and not individual EC2 instances is because if you want 100 worker nodes for a cluster, obviously it's going to be very impractical to create 100 EC2 instances one by one. You want to group them, or maybe you want to have multiple such groups that are all then connected to control plane. And that's why we have the node group. So now let's create node groups and attach worker nodes to the Kubernetes cluster. The worker nodes in Kubernetes run worker processes, right? And kubelet is one of the worker processes. Kubelet is basically the main process that is responsible for scheduling pods, getting all the resources from the servers like CPU, RAM, etc., assigning that to the pod, but also communicating with other services in AWS and the Kubernetes master nodes itself. So kubelet will basically make various API calls, including to AWS services on your behalf. So we need to give kubelet on the worker nodes permission to execute all of these tasks, right? So again, we need to give it a role that has policies attached to it to make those API calls to other AWS services. So that means first we need to create a role for our node group that will allow worker processes like kubelet to perform certain actions. So let's go back to IAM service, roles, and let's create a role for EC2 because these are the worker nodes and kubelet is going to run on EC2. So we're assigning this role to EC2 service. And EC2 service or processes on EC2 service will then be able to do stuff or interact with other AWS services. So I'm going to choose EC2. Let's go to next. And here I have a list of a lot of policies that I can assign to my EC2. We're going to need 3 policies. Let's first of all look up Amazon EKS worker node policy. And let's actually expand and see what is inside. And there you go. This policy includes access to EC2 and EKS. So that's the first policy we're going to need. Let's select that. The second policy we need to give this role for EC2 is container registry policy. And we can choose read only. So this policy includes permissions for ECR. This is the container registry for container images. And this policy contains read-only access to ECR. And this is going to be important or relevant when we connect our worker nodes with the container registry so they can pull the images from there with new versions. Because as you know, AWS services integrate well together. So as long as we give them permissions to interact with each other, we can configure communication between them. So when we push a new image version to ECR, EC2 can download that image from the registry. So that's the second one. And the last policy, the third policy we need to assign this role is Amazon EKS CNI policy. So let's expand that as well. And as you see, this has access to EC2 service, so other EC2 instances, and these are all the actions it can perform on that service. So basically the CNI, as we said, is the container network interface. And CNI is basically the internal network in Kubernetes, so that pods on different servers inside the cluster can communicate with each other, no matter whether they are on worker nodes or control plane nodes or which of those nodes they are located. So that's the common network interface for all of those pods and workloads in the cluster. And we're giving that role access to the CNI policy so that it can interact with other worker nodes or other EC2 instances. So let's check that as well. So we have selected all three policies, and let's go to the next step. We're going to call it EKS node group role, or we can also call it worker node role. This is the default description from AWS. And again, we have these two pieces of information. First of all, this role is for EC2 service. So we are attaching that to EC2 to give EC2 service certain permissions. And then we have these three policies that we selected. And these three policies allow EC2 service and processes running on EC2 service to communicate with other AWS services and to perform certain actions on our behalf. And with this information, we can go ahead and create the role. And there you go, we have our second EKS role for EC2 service. So now that we have the role, we can head over to EKS, compute, and we can add a node group here. Let's call it EKS node group. And here we have the selection for the role that will give node group and EC2 instances in that node group permission for interacting with other AWS services. So we're going to choose the role that we just created, EKS node group role. So as you see, it automatically detects the right option to select because we have multiple roles in our account, but we just see the one that is relevant or matching to a node group. So we select that one and move on to the next page. And these are now configuration for the EC2 instances, because in the background, the node group will spin up EC2 instances. So we need to specify what image that EC2 instance will be based on. Just like when we created EC2 instances ourselves, we need to choose all these parameters here as well. So we have the image and we will leave this at Amazon Linux. And then we have the capacity type. So we have on-demand or spot, and we're actually going to leave this at default. What on-demand basically means is that you pay for what you use per hour or whatever usage of your instances, and you have full control over that on-demand instances. You can decide when to launch them, when to restart them, when to stop them, and so on. And you don't have to pay upfront or basically reserve the instance beforehand. You get that on demand when you need to create that. And it also is guaranteed to be available anytime you want to have those instances, which is what we want. It's an easier and more straightforward option. So we're going to leave that as the default option. We have the instance type. We can choose T3 small. So the type has CPU and memory resources defined here. And we see that for each instance. And this is the storage. So that's going to be EC2 configuration. And right here we have node group scaling configuration. So what is this scaling configuration about? We have minimum size of nodes, maximum size, and desired size. So for example, you can say I want minimum 2 and maximum 4 instances, and the desired instance number should be 3. So it will launch with 3 instances, and it will scale up or down based on the workload we will run in the cluster. And even with little workload, it will still run at least 2 nodes because we set that to minimum 2. And with larger workloads, it will not spin up more than 4 instances. That's what the minimum and maximum limits are there for. Let's actually leave it at 2 as is configured. So this will basically give us 2 EC2 instances at all times in our node group. And using these values, we can actually configure, in addition to that, an auto-scaling for our node group. So we can configure a cluster autoscaler to manage the number of EC2 instances for us based on how much resources is required. So basically we can have this intelligent scaling up and down of worker nodes in our cluster. We can also configure the node group update configuration here. The node groups will be updated by AWS to the latest versions when they are released. So as a kind of fault tolerance setting here, we can define exactly how many nodes we will allow to be taken offline during this update process. We're going to leave that at defaults right now and click next. And this is the network configuration. As I mentioned previously, our worker nodes need to run in a VPC that we have created with these specific configurations. So that control plane, which is running in another VPC on another AWS account, can connect to that VPC and can manage the worker nodes running in different subnets within that VPC. So we're configuring here which VPC and subnets our node group is gonna launch in. We have specified 2 EC2 instances right now for this node group, and here we have 4 subnets, right? That means that node group can launch the EC2 instances in different subnets. And even though right now we have just 2, if we add additional EC2 instances later, if we scale it up to maybe 10 instances, then it will be distributed among different subnets. And in this section here, we're allowing accessing the EC2 instances that we're going to launch using SSH. So just like we did before, we can SSH into our nodes once they get created from our local terminal using the SSH keys. So here we can specify the SSH key we can use to connect to these nodes. And we can actually choose one of the existing ones that we already have downloaded locally. So we can use the same SSH key pair to connect to multiple EC2 instances, or we could also create a new one before creating the node and select it from here. I'm just going to choose an existing one. And this is basically the firewall configuration, right? So we're allowing SSH access to these EC2 instances using this key. And here we can define the sources or who can access these nodes with SSH. All basically says every IP address is allowed to access these instances as long as they have the SSH key, or again, like we did before, we can restrict it only to our own IP address. And we can do that by defining a security group that has configuration that opens up port 22 on the nodes and has our IP address configured as a source. So we can do that as well. I'm going to choose all here, and we can also configure this later once this whole thing is created. So we can configure that later. Let's move on to the next page. And this is our summary. Pretty straightforward. Again, we have connected it to the role, to the new role for EC2 service. We have selected the EC2 instance configuration for all the EC2 instances. We're creating 2 instances in our node group. We can add nodes or remove nodes later. And this is the network configuration. So in terms of pricing, when we create this node group, it will start 2 EC2 instances in the background, which means you get charged for the EC2 instances inside the node group, just like you would be charged when you create this EC2 instances yourself, right? So for EKS cluster, you are charged for EKS service, since it spins up its own resources, etc. So you get charged for service based on time. And for node group, you get charged for EC2 instances that are running in that node group. So with this configuration, we can create a node group. It is in the creation state, so this will take some time. But if we go back to EC2 dashboard, we have instances running here that changed to 2. So these are the instances that we just launched. T3 small. So they have been launched in 2 different availability zones in our closest region. So the EC2 instances got created and the node group is active. So everything is working. And now the node group is connected to EKS cluster as well. So if we go back to our terminal and do kubectl get nodes again, there you go. We see our 2 EC2 instances that we just launched, which are in the ready status. And now that means we can start deploying containers, creating pods and different components in our cluster. So that's how you create an EKS cluster with worker nodes attached to it. And as I mentioned, if, for example, your application grows bigger and you need more compute resources and 2 EC2 instances isn't enough, you can always scale it up by editing your node group scaling configuration. First, we need to adjust the maximum number of nodes to 3 and set the desired number to 3 as well as a starting point, because with a cluster autoscaler, it can then intelligently decide that it can scale it down when it detects less workload in the cluster. And save changes. You see the node group is updating. Let's refresh. So node group is active. The third EC2 is here, but it's still initializing. So I'm going to wait for 2 minutes while the instance continues to start up and then go back to the terminal. That means if I run kubectl get nodes again, now I should see 3 EC2 instances in a ready state and ready to use as worker nodes. Another interesting thing is that the part of initialization of these EC2 instances is installing all the necessary processes on these servers, right? So in order to run pods on these EC2 instances, to make them into Kubernetes worker nodes, basically, we need container runtime on them. We need kubelet to be installed, which is Kubernetes worker process, and kubeproxy, which is another Kubernetes worker process. So all of these things get installed on these EC2 servers when we create them through node group, which is pretty good because you don't have to worry about installing them yourself. In the same way we scaled it up, you can also scale it down by changing it back to 2. Now, of course, you don't want to do this manually all the time. And the alternative for that or solution for that is, as I showed you before, to configure the minimum and maximum size here, and then configure a cluster autoscaler to manage scaling up and scaling down of EC2 instances for you based on how much resources your pods require, right? And the big advantage of that is saving cost of infrastructure. So for example, if you have 5 EC2 instances and your pods are using only 2 of them, and the 3 basically are doing almost nothing, the autoscaler can scale it down to 2 nodes, and then when the resource demand increases, scale it up to 5 nodes. So you can save costs there. So it's absolutely recommended to do that. So as a next step, we are going to configure that autoscaling.